Rate of change is the speed at which a variable changes over a specific period of time. Instantaneous velocity is known as the moment-by-moment rate where an object's position is changing. Average velocity is the ratio of the displacement to elapsed time. Average acceleration is the change in velocity divided by an elapsed time.
From the baseball helmet, so we analyze the data and we use the physics formula to know the position of an object. That is y time equals 1/2 times acceleration times t squared. Y time equals 1/2 times acceleration, that is negative 32 feet over seconds. After substituting the formula with the data that we already have, we simplify and the final result is negative 16 t squared plus 90t plus 700, and this is equal to the position equation for the baseball helmet.
Okay, so the second step, or the second thing that we have to get, is the velocity equation depending on the derivative definition of limits, which is f of x when h approaching 0 is limit f times ax plus h minus f of x over h. So, to make that, we have to use the position equation that we already obtained, and we have to substitute. So, when we make the substitution, we got minus 16 times x plus h squared minus 90 times x plus h plus 700.
After substituting it, we have this equation that is y times time equals limit when h is approaching 0 minus 16 times t plus h squared plus 90 times t plus h plus 700 minus negative 16 times t squared plus 90 times time plus 700 all over h. And the last step, we need to simplify, and is equals b times t equals negative 32 times t plus 9.
The equation of the velocity of the helmet means that it will have a certain velocity over a certain time. And for every second that it has on the air, it will have a different velocity.
So we use the formula velocity times time equals negative 32 times t plus 90. So then we put this to 0 in order to get t. So t plus 90. And then we isolated the t. So we got 32 t equals 90, which is equal to t equals 90 over 32. So time is 2.8125 seconds. So to get the maximum position, we use the formula x max equals 16 times t squared plus 90t plus 700. And we substituted the t with the time that we got, which was 2.81. Squared plus 90.8125 plus 700. And then we solve for it, which gave us 826.5625. So our maximum height is of 826.5625 feet.
Now we have to get the impact velocity, and it is the velocity which the helmet has when it hits the ground. But for that we have to use the quadratic equation. That is, for ax squared plus bc plus x, the solution is minus b plus minus square root of b squared minus 4a plus a times c over 2a. So for that, we have to use the position equation that we got at the first step, which is 0 equal minus 16t squared plus 90t plus 700, and then we got t equal minus 90, which is b, plus minus 90 squared, which is b, minus 4 times minus 16, which is a, times 700, which is the c variable, over 2 times minus 16. In the process of simplifying the last equation, we got time is equal minus 90 plus minus square root of 52,900 over minus 32. As we have two values, we will also get two values for t. We will get minus 4.375 seconds, and the second value will be 10 seconds. But as time, we will use the positive one because we cannot have a negative time. So now to get the impact velocity, we will use the velocity equation, which is velocity equal minus 32 time plus 90. Now we substitute, and it's equal minus 32 times 10 plus 90 is equal to minus 230 feet over second. So that is our impact velocity.
We substitute this equation with the velocity equation, that is velocity times time equals minus 32 times time minus 90. And we substituted in the formula, and the final result was velocity times time when x is approaching 0 equals the limit minus 32 times time plus h plus 90 minus negative 32 times time plus 90 all over h. And after simplifying, the final result is the acceleration is equals to 2 feet over second square. So after simplifying the result, the final answer is acceleration negative 32 feet over second square. And this is our acceleration after 2 seconds.
In order to solve this problem, we had to analyze and investigate about this subject, in order to gather the formulas that we needed to solve for the limit and for the maximum position of the helmet. Then we had to calculate the impact velocity of the helmet, and also the acceleration of the helmet after 2 seconds, by using the derivative equation. And finally, we had to investigate the average impact velocity of a helmet and determine if Alex's helmet was intact. With this project, we were able to notice that motion situations happen all the time, and limits and kinematics are closely related when it comes to calculating approximations of a certain value. In order to do that, we needed to use a lot of formulas in order to get all the variables that we needed in order to solve these problems. Here we can see how Melissa throws her hat from a 700 feet building.